Well, I want to thank you for being part of this platform. And we are grateful to God who has kept us up to now. And we are into our third lesson as of now. So as we get started, as our usual norm is, we give a word of prayer for God to guide us through this lesson. Then as we progress, please, I know we get to know that our microphone should always be mute, and then in case you want to speak, you can always unmute and then share with us what you have. Okay, before we get started, we would request someone to give us a word of prayer, and Zoa Gloria wants to do so. So Gloria, your hand was up first. Please, you may say a word of prayer and then we get started. Thank you.
We pray. Heavenly Father, we want to thank you for this beautiful morning. We thank you for your love. We thank you for your care. And we thank you for your provision. We thank you for everything you have done for us. As we are going to continue with our lesson, we call you to come and prevail wherever we are. We call you to come and be with us in whatever we are doing. We thank you for our teachers as we are going to continue with this lesson. Come and be with him. Come and guide him. Use him as your vessel. We thank you and we give you glory and honor. In the mighty name of Jesus, I pray with thanksgiving.
Amen. Amen. Thank you, Gloria, for that prayer. And as we move on, we've been looking at probability. And today, I want us to share something still under probability to see how we can deal with the dice, and then how we can deal with the coins as far as the probability is concerned. So I'm going to share something here. Okay. Let me hope my screen is visible. I request that we use mostly the text to communicate, unless someone has something to say out. But I think our texts will be far more easier and far more quicker to give you a response. Okay. Now, I said I want to share with you how we can deal with tossing coins and then tossing the dice as well, as far as the probability is concerned. Now, we have several scenarios we are going to look at as far as this is concerned. We shall see how do we toss a coin, like when we toss a coin, what outcomes do we expect? And how do we calculate different outcomes that they have told us to come up to calculate? Then we shall also look at the dice. How do we deal with the dice when we are supposed to toss the dice and then roll the dice, and then you see the outcome, and then they can tell you, give us the sum of given numbers, give us what is the probability of picking even numbers and everything. So that is literally what we are going to share throughout this lesson, so that any question that comes as far as the dice and then the coins are concerned, we should be able to handle it very well. Okay, so we are going to start with the tossing the coin. Now, when you toss a coin, all of us must be aware that a coin has two faces. Okay, it has the face of the head, and then we also have the face of the tail. Someone is asking which subject. We're in senior 3 mathematics. This is the lesson. This is what we are on. Senior 3 mathematics. Okay. Please, I want your questions to be directed to me when you're communicating so that okay, please direct your questions to me if you need something to be clarified about. Just direct your questions here to me. So I'm saying that when we talk about the coin, I'm going to start with the coin, then we shall move to the dice, and then we shall see how do we deal with both scenarios. So all of us, when we are saying that when we get any coin, all coins that we have, they have what we call the head, and they also have the tail. So when you toss it, there are chances that if it is one coin, I'm going to start with one coin. When you toss one coin, you will expect the outcome will be, and you're tossing it once. A coin, you can toss it once, you can also toss it twice, 3 times, and so on. So when you toss a coin once, we have two items that we expect. You will expect either the head or you'll expect the tail. So in so doing, the outcome will either be H or T, but not both. So this is the tossing now. You may take note of some of these items so that when you're working out, you will follow those notes as well. Or you might also get them from the Google Classroom at once, and then you'll share. So we are saying that when you toss a coin, this is our coin, and we are tossing it once. This is our coin. And when you toss it once, you'll expect either the head or the tail. And remember, our formula for probability of an event is the number of the event out of the number of the sample space. Now here, as we are tossing a coin, we are finding out what is our sample space here. Okay, so our sample space here, we will have a set having the head and also having the tail. This will be our sample space. So when they ask you, what is the probability of finding the head is 1 here. So that the number here will be 1. Out of the sample space, how many items do we have here? We have 2 items. So the number will be 2. So what we should know is when you are tossing a coin once, one single coin once, this is what we'll expect. They'll ask you what is the probability of finding maybe a head or a tail. Okay, that means this is what we shall have. This is for that scenario where you have only that. Now, there are several scenarios we are going to look at. Okay, there are several scenarios we are going to look at. Now, this is for only that one scenario. So we expect our sample space to be equals S is a sample space, which will have the head and also the tail. Now the number, take note, the number in the sample space, which is n into brackets S, that is the number in the sample space will be 2, meaning it will have you count head and then tail. This is one item, this is the second, so you have 2 as your sample space. Now, that is one scenario. Now, there's also another scenario. How about when you toss 2 coins? Now, take note of this. We have 2 things here. You can be tossing 2 coins once. And I've also said, or tossing 1 single coin twice. These are the same scenarios. When you get 2 coins and then you throw them at once, it is the same as another person who has gotten 1 coin and thrown it twice. So that is why we are saying a question might arise in this form. Either a coin is tossed twice or someone tossed the 2 coins at the same time. So this is the other scenario. So in so doing, what do we expect? So we have, remember, 2 coins. This is our first coin. This is coin 1. and then this is coin 2. Coin 1 has the head, it also has the tail, while coin 2 also has the head and also has the tail. Now, what are the possible outcomes? What things would we expect when you toss it? You'll either get, this is how we are matching this. This head with this one here will produce this outcome. So you either get a head from coin 1 and also a head from coin 2. Okay? Or you can either get the head, this one, and this, either the head from coin 1 and then the tail from coin 2. So you have head and then tail. Then here you also either have the tail from coin 1 and also the head from coin 2. Or you may have both surfaces having the tail. So in so doing, someone saying, so the sample space is the same for both? No, it's not the same. Okay. Passes, can you ask us where you lost from? Passes, can you unmute? Passes. Passes, can you unmute? Is Passes there? Passes, can you unmute and then you ask your question?
Sir,
Mm-hmm.
sir, like I'm saying, I'm lost on that part, or like from the whole thing, because I've just joined the lesson and I'm trying to read through, but I'm not understanding.
Problem, you've just joined through. Okay, let me request you. Okay, someone. Let me request someone who is following here. Oh, is this Karen? Is Karen there? Karen, can you unmute? Karen?
Yes, teacher.
Are you following what we are looking at here?
Teacher, almost. I joined like a couple of minutes like before.
Okay. People join the Nachimoli. Yes, Nachimoli?
Yes, sir.
Are you following?
Yeah, I'm following.
Now, can you help us explain this first part here? Let's start here from what you
Yes.
said here.
We are looking at probability where you're tossing a coin and a dice. At first, we have said that tossing a coin once, and we said that you may toss a coin and there is a probability that you're going to find the head or the tail. So if you're told to toss a coin once to find the probability, it will be, we know that probability equals to number of expected chances out of the total sample space. So the number of expected chances, you remember we have the head, a coin has the head and the tail. There is a possibility that you're going to find a head or a tail. So the expected chances it will be 1, because so it can't be possible that you're going to toss and then a head and a tail come at once. Then the total sample space will be 2, since the coin has the head and the tail at once. Thank you, sir.
Thank you. Thank you. Now, I am repeating this. I think the challenge you have is people are joining late, and I think that's where the trouble is. Now, I think I'm repeating this once again. We are saying that in our probability, we are looking at how do you deal with the coins and then the dice. That is what we are looking at. And we are saying that we are starting with a coin. when you have that coin, a 500 shilling coin, that coin has only two faces. And when you toss it once, one of the faces will appear. So meaning the things, the items that appear will show that as our sample space. And we are saying when you toss it, you'll either have the head or you will have the tail. Okay? Please let's pay close attention on this. You'll either have the head or you'll have the tail. So meaning our sample space here will be H. H is representing the head, T is representing the tail. So meaning our number of the sample space here will be equivalent to 2. We are counting the items in this set here. So we shall have the 2 as our sample space. That is when you toss it once. Okay? When you do it once. Now, we are looking at several scenarios. So when you toss it once, this is our sample space, and this will be our number of the sample space. When they ask what is the probability of finding a head, we know that probability is equal to the number of events, okay? The number of events out of the number of the sample space. So if they say, what is the probability of finding a head? Count how many heads you have in this sample space. It is only 1. So meaning we shall have 1. Two, we shall have 2 at that point. So meaning this will be our probability. Good. So we move on. So in the next thing we are looking at, how are we dealing with the 2? You're still seeing my screen? Can you type to confirm if my screen is still on?
Your screen is fine.
Okay. Yes, good. So here we are on the second part. What if we are given, we are saying, what if you now have 2 coins and you are being told to toss them? And I was saying that having 2 coins, if you have 2 coins and you're tossing them once, it is the same as having 1 coin, tossing it twice, meaning the sample space here is the same. Okay, it is the same. We have the same sample space here. So in so doing, we will create, now we first come up with our tables. This is what I want us to start building on. So this will be our table. The table is representing this, that the first coin here, coin number 1 has the head and has the tail. Coin number 2 also up here has the head and also has the tail. So inside here, we are asking, what are the possible outcomes? What possible outcomes shall we get? So meaning we are corresponding this one to this one, meaning in the first coin, you may have the head and the second one also have the head. Or you may also have the first coin might give you the head and the second coin gives you the tail. This is how you're generating our table. Or the first coin can give you the tail and the second one gives you the head. And lastly, the first one can also, all of them give you the tails. So that's why you're seeing TTHH. Now, what will our sample space be? Now, the other way that we can also represent it in this form now. This is how we are explaining this. So this is our coin. We have our coin here. When you toss it once, this is one time, for the first tossing. You'll either have the head or you'll have the tail. When you toss the second time we are now using this. This is now second time. This is second time now. This is the first time. So also in the second time, you either have the head also or the tail. Also this side, you also have the head and you also have the tail. So therefore, Therefore, how do you generate your sample space from here? Follow this route here. We have head. This will be our first outcome. You also have head, tail. This is also another outcome. Okay. We are getting the other one. This one is tail, head. Then you get this outcome here. Then you also have tail, and you also come up with this. Why do we? This is the tree. This is the probability tree. And then you also have the probability tables. You can utilize any of them. This is the tree and this is the table. So it is either way you can use one of them. It's not that you are supposed to use both of them. Okay? So you can either come up with a table, but you will come up with the same sample space. You realize that when you see the sample space here, it is the same as what you have in your table. Now, we have a task. What is the sample space? What will be our sample space here? Can I have someone raise up the hand to tell us our sample space here now? Nachimuli Olivia. Yes, Olivia. Nachimuli, can you unmute? Nachimuli, you can unmute. Good. So Nachimuli, yes.
It is 4.
The sample space. Give us the sample space. Not the number.
The sample space. It is 8.
No, we are saying.
Yeah.
The sample space, not number.
It is the head, the tail, and again the tail, and again the head, again the head,
then the head,
and the head,
and head,
and again the tail,
then we have the tail,
and the tail,
and then the tail.
Yes.
Correct. Class, this is what we are doing. How are we getting our sample? Please, there is sample space and number of the sample space. So our sample space will be these items that we are getting. Meaning in your tossing, you will either get so we are saying our sample space here is being generated from here, these items that we do have here. Okay. So if you have your table here, this is the first sample space element in the sample space. This is the second, this is the third, and this is the fourth. So meaning our number of the sample space will be equivalent to 4. Okay. That will have our sample space. So how are we getting the 4? We are getting it from here after generating the table. Okay. After generating the table, you will have those given items, which we have listed here, and they will make up our sample space. Okay. Blessing, you have a question? Blessing?
No, sir.
Okay, good. There is Marvin. Is it Marvin? Okay, there is no question on that. So this is what we are going to generate. So this is what we shall generate at the end of it all as our sample space. Now remember, as we are saying, is that you first generate either from the tree or from the table. Okay? From either the tree or the table. One of them, you can generate them. Okay. So So this is what we have for the 2 coins. Unless someone has a question on 2 coins before we move to another one. Simwe Daniel.
I beg your pardon on how to get the sample space.
Oh, good. How do we get the sample space? We are generating, if you've seen our table here, you pick all the elements that you have in your table. Okay? So you pick all the elements that are in the table. So you have here, like, let me use the table. Table can bring out to something quite easily. The table might bring out something a bit more easier. We have here H, we have T for the second, and also H, and then T for the very first one. So you keep matching. This and this is HH. This one and the other one is HT. That is, and those are outcomes. Then this T and then the other H will produce an outcome, TH. Then this other T and then the other one will also produce an outcome. So therefore, whatever you see, these are now outcomes. That when you throw those coins, they will show those ones on top. So this one will be for coin 1, coin 2, coin 1, coin 2, coin 1, coin 2, like that. So that is what we shall have. That's how we have our sample space. So meaning our sample space will be equivalent to the HH, okay? That HH as we have it there. Then HT, okay? We have our HT as that. Then we also have the bottom one, TH. Shall also have the TH as a sample space. Then we also have the TT as the sample space. So the number of the sample space, you count those items inside there. 1, 2, 3, 4, which will be that. Please don't count H alone. Don't count H. Some of you might count one H alone, the other H. No, don't count like that. These are outcomes. So you don't count you count the 2 as they come out together. So that's what we shall be having. So that's how we are generating our sample space. Moronji, about tossing 2 coins. Yes, Moronji, Davis?
Excuse me, teacher.
Yes.
What about if you are tossing 3 coins? Do you get the same sample space?
No, it's not the same sample space. This is for only 2.
Okay.
For 3, you don't get the same sample space. It's a different one.
Okay.
Good. Karen, your hand is up.
Yes, teacher.
Your hand is up.
Teacher, I have a question.
Yes.
You said both the tree and the table can work for when you're tossing 2 coins at once and a coin twice. But then it's like the tree only works for the when you're tossing a coin twice because it has only 1 coin. Just like the way you showed us.
What we are saying is the outcomes are the same. That's what we are looking at. Okay, we are saying the outcomes are the same. That is what we are generating. Okay, good. All right, now let's move on. Let's move on to the other one. So, most importantly, members, is generating the outcomes. That's what we are looking at as most important. Let's go to another thing. So that is our sample space. Now, what happens when you toss 3 coins at once? Or you are tossing a coin 3 times? You're tossing 3 coins, you're getting 3 coins, and then you're throwing them at once. So you'll see what will come out. Then getting 1 coin, throwing it 3 times. What is the main point is what is our sample space? So now this is what we have. This will be our table. So we generate, this is the, remember the outcomes for the 2 coins. Okay. Remember our outcomes for the 2 coins. This is the outcome for 2 coins. And then this is 1 coin to come up with the to come up with 3. So meaning we get the outcomes that we got in the other 2 coins that we worked on. We have just worked on previously. Then we put them up here. Remember, there were 4. These are the 4 that we have. Then the other 1 coin will come in at this point. So you start matching through. So you have H, it can either be H 3 times, or you may have HHT, or you may have HTH like that, or you may have HTT. Okay, then this one also. So how are we? Someone might ask, how are we getting this H? This is for tossing 2 coins. This is for tossing 2 coins. This is for 2 coins here. Well, this is 1 coin. This is 1 coin. So when you match through, this will be your sample space. This is the sample space we are asking. Someone asked about what happens when there are 3. This is what we have. These are the possible outcomes that when you throw them, either at the same time or one at a time, we will expect this one as the outcome as far as our work is concerned. So the point is, this is our table. This is how our table will be like. That's how our table will be like. Teacher, I've not understood the one of for 3 coins. We're on 3 coins. This is where we are. So we said we generate, our table is generated from the 2 coins and then the 1 coin. Please, we are matching. You see, when you get this one to this, you will see this. Then you get also this one to this one here, you'll generate this HTT, HHT. Then when you get this same one, and then you match with this one, you generate this. Then when you get still the H, and then you match it with this one, you will come up with that. So you do the same thing to this one, to the T. So the tail, and then the other 2 heads. The tail, then head, tail, like that, until you come up with your table. Now your sample space S. How will our tree look? This is our sample. This is how our sample space will be like. So the sample space will be generated from, we shall have this here. I want to this. So our sample space will have, this one is for this first tossing. Second tossing, we will have this. Third, we shall also have this one here like that. Okay, so you generate them up to here. Then we also come and add these ones here to this. Then we shall also have this one as well, and we shall also have these other ones as well, like that. Okay, so this will bring up our sample space all together. The point is knowing that to come up with the 3, you need to first put the one of the 2 coins up here, and then the one for the 1 coin across. Then you come up with your sample space. So our number in the sample space will be equivalent. You count these items here. This is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, and 8. So your number of the sample space will be the 8 for the 3 coins. So you see that tossing 3 coins is not the same as the one for 2 coins. The sample space is different. So questions can arise. What is the probability of getting at least 2 heads? At least 2 heads. Can't we use a tree? The tree is here. Someone has just asked, can't we use the tree for 3? We can use it. Now the tree is meaning you're tossing this 1 coin 3 times. Okay, you're tossing this 1 coin 3 times. The way, as someone explained, that you cannot get you may not get the other 3 again throwing them at once, maybe 3 times. It's also possible, but the tree will provide for you how you will throw 3 times. So in the first throw, you'll get this. Okay. In the second throw, as we saw, we shall get. So you generate your tree from this. So this one we'll have a sample space of either head and tail. When you again toss, this one will also have a sample space, head, tail, like that. This one also have head, tail. Then for the second one, you also generate a tree from this point here. So you realize that this is once. Let me label them so that we can easily see. So when you're tossing through, this is the first tossing. In the first tossing, you have these two outcomes. Second tossing is this one. This is all for second toss. When you do the second tossing, remember our outcome we got for 2 coins. This will be our outcome here. Then when the third time, remember the tree keeps on expanding. The more you toss, the more it keeps on expanding. Then you'll have this one is for 3. This is for 3, and the last one for this tossing here. Okay. Now, as I said, tossing a coin thrice, you'll get the same outcome as tossing the coin once. When tossing 3 coins once, the outcome will be the same. Okay. Though the method of doing it may not be the same method of doing it, but when you toss out, this is what you will get. So how do you get your sample space? Look from here. This line here will generate for you the first sample space. See? Then this one here will also come from here and then branch off at this point. So you have HHT, which will be this. Then when you have this one also, you'll get this one from here to get the other, the third one. HT, we are moving like this until to that. Then you still move from HT like that. Okay. Then you raise them like that. So you see that your possible outcome will come towards the end at this point here. Okay. Can you do a topic? Yes, we are going to do some questions here. Don't worry about that. The questions are here. We just need to find out the sample spaces first. And we are going to use those sample spaces to answer these questions. So once you have these ones, that means you have your sample space here, and you also have your outcomes as well. So your number of sample spaces are 8. Count. This is 1, this is 2, this is 3, this is 4, 5, 6, 7, and then 8. So you see that your 8 will be the sample space. Okay, let me get some questions. Harriet Lace. Harriet Lace?
Yes, sorry.
You have a question?
Yeah, there are 3 coins, yeah?
Yes.
Why have you, on a tree, why have you made 1?
On the tree. Now, this one here, you know, on a tree, you cannot have 3, you cannot represent the 3 coins at once. On a tree, we get 1 coin and we keep tossing it 3. Actually, the tree represents this one here. Tossing a coin 3 times.
Yeah.
That's what the tree is saying. But we also say that tossing a coin 3 times is the same as tossing 3 coins once. So they toss this one here, this one 3 times is 1 for the tree, and then this other one will generate it for the table. That's how we are coming to that. All right. Olivia? Yes, Olivia.
Yes.
Your hand is up.
Sir, on the 2 coins, the expected events, what will be the expected events? Will it be HHTT?
Yes, these are the one for 2. HH, TH, TH, HT, TT. These are for 2 coins. The one in the previous is the previous one, yeah?
Yes, the expected events.
Yeah. No, events we have not been given yet. Where expected sample space will be the H, this one here. HH, HT, TH. These ones are the ones for the expected ones. The sample space, that's what we expect. But the events we always ask in a question. We are going to see the questions. In the question, that's where the events come in from.
Okay, thank you, sir.
You're welcome. Okay, so members, that is how we will come up with our sample space. Can someone, Blessing is saying, can you toast 4 times? Yes, you can now generate, based on this one, you can now generate it for the 4 times. So meaning for the 4 times, you would instead get 2 coins here, get 2 coins here and then 2 coins the other side. Then you come up with, I will actually give you that to try to work out for the 4. Okay, so let's look at an example as someone was saying. We are looking at an example that we are having here. And we are saying, still remember we've generated our sample space already. So sorry, our sample space. So literally what we are going to do is to keep using that sample space to generate our result. So I say 3 coins are tossed. State the probability space and use it to find the following. Now we've already got the probability sample space. When you toss 3 coins, this is our sample space. This is our sample space. We said when you toss 3 coins, maybe let me remove this. When you toss 3 coins, you say this is our sample space. So remember, the first thing you need to do before you answer anything, first generate the sample space. Don't guess. First generate the sample space, as I've given you in this table here. That's the first thing you need to do. If you can't generate the sample space, it will be very difficult for you to come up with the answers. So as we've generated our sample space here, they are telling that we are being told to find the probability. We are now here. Find the probability that you get 3 heads, the probability of finding 2 heads, and the probability of finding at most 1 head. That's the question. The people wanted questions. That's how the questions are phrased. And when you check through. So if we say, let's work out with A, start with A. What is the probability of finding 3 heads? Okay. The probability of finding 3 heads. That is what we have. Now, what you do, we first generate our events, our number of, actually first find the events. Or maybe we can say, let's the probability, let's the probability of finding 3 heads. We can give it 3 heads. We can call it A. Let's call it A. Let's give it a name A for providing 3 events, for 3 heads. So what is this? What is the set of events? Okay. Is it okay if you put the question? I'm going to put it back. So we are saying, we put back the question. So we are saying, we are letting this one, the probability of finding head to be A. Okay. So first thing, remember it is tossing 3 coins. Let's go back to our table, assuming we've already generated our table. 3 heads. Look into your sample space here. How many in your set here? How many do you have of these outcomes are having 3 heads? That's the first thing we need to find out, because we need to first find the event, and the event here, we've called it A. So in A, what do we have as the 3 heads? How many do we have? How many events are having 3 heads? Yes, Tracy Hope.
1.
How many?
1.
Pardon?
It is 1.
Give us, it is 1. When you look at this sample space here, we only have this HHH, 3 heads. Here, there are 2, so this one doesn't qualify. Okay? Here, there are also 2, this one doesn't qualify. Here, it is 1, it doesn't qualify. Here, there are 2, no qualification. Here, you see there is only 1 like that. So you realize that this one even has no head at all. So meaning it is only 1 event, which is the triple H, 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 H. Huh? So this will be your event now. Someone who was asking about the event. So having got that one, we are saying our event A is equivalent to the H, the H 3 times, which is only once. So meaning our number of events, our number of A, which will be our number of events, is equivalent to 1. That's what you have. It is one event. Therefore, the probability, the probability of finding A, remember our A is representing probability of 3 heads, will be equivalent to the number of events, which is the number of in A, out of the number of the sample space. Remember our sample space was 8. Let's go back and see. Our sample space here, 1, 2, 3, 4, 5, 6, 7, 8. This one is 8. So our sample space is constant as 8. Okay. So when we do that, we shall have our 1 out of the sample space S, which is 8. And that will be our probability. If you want to simplify it further, you can simplify it. But if it cannot be simplified, you leave it in that given order. Simple as that. Let's look at the second one. Probability of finding 2 heads. Probability of finding 2 heads. Probability of finding 2 heads. Okay. Probability of finding 2 heads. So we say let the probability, let's say let probability of finding 2 heads. Okay. Let probability of finding 2 heads. We call it, let's call it B. Let that probability be B. So first thing, we find the set B. What events are in set B? I want someone, I'm going to pick on someone who can give us was Philomena Bakitha. Are you there? Philomena Bakitha? You're
yes,
on stage.
teacher.
Can you give us from this list that we have, what will be our events for 2 heads? For set B.
Teacher, I'm sorry. My network was disturbing. That's why I was raising my hand for you to please explain for me.
Oh, okay.
Yes.
Okay, I get it. Hey, let me see who else is there. Blessing, Josia. Josia, Blessing, you're there?
Yes.
Good. Can you give us the events in B? List for us.
HHT.
We have H, T.
Then THH.
T, H.
Then
Is that all?
no, HTH.
We also have H. H what?
TH.
HT, HTH. Good. So this will be our events. Thank you. So we've now generated our events there now. Please, more important. So the issue is we need to see, when you look at your sample space, you are looking out in that sample space, where do we see 2 heads? That's what we want. Where do we see 2 heads? It's what we need to look out for. So when you look at here, we have here 2 heads. Here we have 3. So meaning this one doesn't qualify. Here we have the 2 heads there. Here we also have 1, 2 heads here. Okay. Here we don't have, so this one doesn't qualify. Then we come to this one. 2 heads are there also. This one doesn't qualify. This one doesn't. This one doesn't, because it has 1 and the other one doesn't have. So therefore, our events will be 3, 1, 2, 3. That will be our B. So we move, we substitute here and we say our events will be that, and then will be the ones that we've listed. So meaning the number of events the number of events in B will be equal to 3. So when you substitute here for your probability of B, those of you who have got the answer already, what will the probability of B bring out? Joel says 3 out of 8. Any other person could confirm Joel's answer? Can you type the answer? Type the answer. Can we type the answers? Type the answers in the chat. Waiting. Sonia Joel with an answer. Grace, 3 out of 8. Good. Kezema. Good. There was a question from someone. Okay, maybe let's. So the answer is 3. All of us are saying 3 out of 8. Good. 3 out of 8. 3 out of 8. All of us are saying 3 out of 8. Correct. Now, someone asked something interesting in our inbox here. I don't know if some of you are also asking yourselves. She said, why are we not taking this 3H, and yet they said 2 heads? This H here has 3 heads, but they have, the question is saying probability of 2 heads. We have not said there is no at least or at most or what. No, it is only 2 heads. So you don't look for 3. Okay, we don't look for 3. So meaning we are looking out for only 2 heads is what we are looking out for. Then when we say at most 1 head, meaning the maximum number in that, can we first find a sample space for at most 1 head? Who can give us that one there? Who is there? Asimwe Daniel. Asimwe? Is Asimwe Daniel there? Asimwe is not there. Okay. Yes, Nachimuli. Yes, Nachimuli. Nachimuli, are you there?
Yes, sir.
Can you give us the sample space for at most 1 head?
We have HTT.
HTT.
We have THT.
THT.
We have TTH.
TTH.
And TTT.
And then TTT. Is that all?
Yes, sir.
That is all. Okay. So, so this is what we have. Sorry. So this is what we have as our items that we have there. But teacher, why? Now the issue is at most. Someone is asking, why should you have TT? Naturally. Why are you having TT? We are asking. Philomena is asking, why do you put TT?
Because they were not specific, saying that we should only include those ones which are having H. But at most, that means that even the number that does not have H somewhere goes in.
Good. So we are saying at most, meaning the maximum number. This is what we say. The maximum should be 1. So meaning you may have 0. In the numbers you have 0, 1. If you say the maximum is 1. So meaning even the 0 will also be part of it. Like even those ones without will be part of it. Meaning 2 is not part of it, 3 is not there. These ones cannot qualify. What qualifies is the one with the maximum number of the heads there must only and only be 1. So that is what we do. This is how we shall generate our sample space. Good. So literally, so here we shall have 4 out of the 8. So the number of events is 4, and then the sample space there is 8. Now, how about HHT does not qualify because there are 2. And 2, remember, most meaning maximum. Most means maximum is 1. So meaning if you have 2, it means it is not part of it. Okay, but you look for where there is 0 head and also 1 head. Okay, so thank you very much. I think we've picked up something as far as the heads and then the tails are concerned. So I have some more questions here. Maybe briefly, I know some of you can read these notes here. I know in the next week we shall look at what you do when you're tossing a dice twice. When you toss a dice, when you look at your possible outcome, I'm going to look at these tables here, but they are going to remain in our notes. We are going to keep them in the notes. There are some questions here that we are going to attempt. Actually, I'm going to upload them on the. I'm going to upload them on our. I'm going to upload them on our Google Classroom right now. I think as soon as we finish the lesson, we are going to see them. We are going to say a fair coin is tossed once. Find the probability of a head, not a head, head or tail, a tail, not tail. All these ones here. So I want you to work them out. And also these ones here. Actually, there are 2 questions. I want you to work out to question 1 and then question 2. It's just about what we have worked out. Okay? It's just what we have worked out right now. So I'm going to post them there, and then we are going to find those probabilities. But still, we are drawing going to draw our tree first, or you use the table, and then after that, you start calculating. Okay, you calculate out these probabilities as I've given them to you out here. Teacher, can a fraction be reduced in case they can be? Yes, you can reduce a fraction. If you have 4 out of 8, you can reduce this one here to 1 out of 2. It is very fine. You can reduce those fractions. Unless there's another question. Any other question? Any other question? Any other question? So please, you're going to get your notes on following the Google Classroom. I'm going to put the notes and also the questions there also. Okay, and then we shall work through. Unless someone wants to say something, someone wants to say something. I want to pick on one. Yes, Nachimoli, your hand is up. No.
Yes, sir.
Yes, your hand is up.
No, it was a mistake, sir.
Right.
I just wanted to inquire whether you can divide a probability, but they have already asked that. Thank you,
All
sir.
right. Thank you. Tizzy. Can you say? Your hand is up.
Yes. Good afternoon, everyone. Mine is just a question. Like when you join using these links we have seen, is it where you find the work or you have to download the app first?
You can join and then someone is going to answer for you that, just briefly. Mr. Kakuru Bernard is going to answer that.
Okay.
If you're not there, good. Moronji? Yes, Moronji? Moronji? Moronji, are you there? Okay, Cuthbert? Yes, Cuthbert?
Yes, yeah.
Yes, your hand is up. Okay, noted.
Teacher, I wanted to inquire.
You want to inquire?
On set theory capability. Is it the same way we do?
No, we don't do it the same way with the trees and these other ones here. It's quite different. Okay. Maybe let me request Mr. Kakuru. There are some people who are not yet there on the accessing the work. They have not yet been there. Maybe you could help them out before we close the lesson. Mr. Kakuru?
Okay. Yes, I'm there. That screen is mine. So for those who haven't joined the WhatsApp groups, you haven't joined the Google Classroom, first of all, I sent you the link. The link looks like that. When you check in the chat, that is the link. So when you tap on that link and maybe you open it, it will look like that. It is telling you to join the e-class. When you look here, these are the different options that are there. You can download the timetable from there. If you have brothers and sisters in nursery, P1, their link is there, the one they use for joining classes. Then if you want to join the WhatsApp groups, you can see the link is there. You can join nursery from there, P1. These are WhatsApp groups. So when you tap there, it automatically takes you to join. It brings the link. For example, if I click on this of senior 5, if I click the one of senior 5, this link here, when you are using the phone, it will automatically take you to that class. So you can even join the chat from there of that WhatsApp. So when you click there, it takes you there. Then the Google Classroom codes are here. This, for example, this is the one of verse 5. So when you use that to join, and then if you tap on this link immediately, it takes you to that class. If you simply tap on it, it will take you to that classroom. So that link, use it to go to Google Classroom, use it to go to the WhatsApp group. So it has all of those. So now here I'm in S5 class. I think this was S3. Even though I go back and I pick S3, it is the same thing. So here you want to pick S3. It takes you to the Google Classroom of S3. Let's say maybe you want to follow the same process. I can have someone using a phone. You demonstrate. Who has a phone? Raise your hand and we pick you so that we direct you. Let me pick Joyce. Joyce?
Yes, please.
Are you using a phone?
Yes,
Have you joined Google Classrooms or not yet?
I have joined.
What's the problem?
No, the problem, I just wanted to ask teacher while he was still in class.
Oh, okay.
Something.
Let me pick another person about Google Classroom.
Okay.
Davis. Davis. Have you joined Google Classrooms? This one is not willing to speak. Let me pick Avalon. Avalon. I want someone who has a question on Google Classroom. If it's not there, we can close the meeting. Susan? Susan? I see TechnoSpark. Let me accept TechnoSpark. Seems those whom I'm asking to unmute, they don't want. Let me check out TechnoSpark down here. Is TechnoSpark what? TechnoSpark 2? Can you speak?
Yes, teacher.
Do you want to ask about Google Classrooms?
Teacher, me have not yet joined the Google Classroom.
Do you know how to share screen and I direct
Yes,
you?
teacher, are you hearing me?
Yes, share the screen.
No.
Share the screen. Share
My
the screen
screen?
and I direct you. Yes. And under Zoom, tap on share. Tap on share.
Okay, let me check. Under Zoom.
If you're not ready, we are going to share a video in the WhatsApp group that will guide you to complete the process. So someone is asking, why are the classes ending on 13th August? So from 13th August, we are going now to task your schools to continue with what we have been doing. So we have different administrators for each level. So you will find that maybe like Mr. Kakuru is in charge of your school to continue with the digital learning. So for you, I've shared the screen. I want you to go to the apps, click share, then screen. You choose the app. You go to your screen, like when you are showing me the apps.
Excuse me, teacher. Excuse me, teacher.
Yes, Joyce?
Can I do that?
Yes, share your
And at
screen.
least demonstrate for them?
Yes, but you said you already have it. I wanted someone who doesn't have it.
It's me, I don't have it, but I'm trying to.
But you are
Excuse
sharing
me,
wrong
teacher.
things, and yes, you are taking longer. Okay, let me allow this one who has shared to speak. Let me hope you don't have the classroom app on your screen. I'm trying to get him so that he can be. Yes, can you tap to unmute? Unmute. Yes. Do you have the Google Classroom app? Go to share there. Then you go to Play Store. Go to Play Store. Play Store. There. Open. Then search the app. Go back a bit. Search. Go back to search. Play Store. Then search for Google Classroom. Google Classroom. Google Classroom. Can you search? Are you there? Google Classroom, then you search. Yes, but okay, now it is there. Then choose open. Open it. Can you open? This one is already in the classroom. I wanted someone who is not yet there. Those who are complaining that they are not yet there. This one is already in the classroom.